Today we want to talk about the ambiguous case of the law of sines. This is the case where we're given two sides and the angle opposite one of those sides. The unambiguous case of the law of sines is when we're given two angles and one side. Because once we have two angles, we have three angles. We're just subtraction away from three angles. But this case, where we're given two sides and the angle opposite one of those sides, that's the ambiguous case of the law of sines. So I'm going to refer to the two sides. Since one of them is the side opposite the given angle. Sometimes I'll just abbreviate that by saying side opposite. And then I'll refer to the other given side. It's not really fair to the other given side that it's just the other given side, but it's the other one. So we have the side opposite the given angle and the other given side. Remember that the ambiguous case of the law of sines can lead to 0, 1, 2, or 1 triangles. So it's ambiguous because it could lead, this set of given information can lead to 0, 1, 2, or 1 triangles. And I know I listed one twice, but it can lead to one triangle in a couple of different ways. But this is why it's the ambiguous case, because we can lead to 0, 1, 2, or 1 triangles. Remember, the setup is that we have a side, two sides, and a given angle. So if we start off by drawing I think I used the other colors yesterday. So let's suppose that this is the other given side. We have a given angle. And this horizontal line down here is where the third side is going to go. So depending on the length of the side opposite the given angle, that could result in 0, 1, 2, or 1 triangles. So this right here, between this point, this end of the other given side, and the line where the third side goes, that's where we have to put the side opposite the given angle. So that's where we put the side opposite the given angle. And we can see that we get zero triangles if the side opposite the given angle is too short. There's a certain amount of distance it needs to cover. It can be too short where we get 0 triangles. It can be exactly this length where we get 1 triangle. It could be a little bit longer than this height where we get 2 triangles. Or if it's longer than the other given side, then we get 1 triangle again. So if it's too short, we get 0 triangles. If it fits just right, if it equals the height, we get exactly 1 right triangle. If it's longer than the height, but shorter than the other given side, then we get 2 triangles. Between the height and the other given side, we get 2 triangles. And then if it's longer than the other given side, then we get 1 triangle. yesterday I mentioned that we don't have to determine which case we are in. We can, but we don't have to. The numbers will tell us how to determine whether we have 0, 1, or 2, or 1 triangle. So we can calculate the height, but we don't have to calculate the height. Let's look at an example. So I'm going to say the given angle, I'm going to call that, let's see, I'm going to say side B is equal to 10. I'm going to put centimeters on to emphasize that B is a height, or sorry, a length. And I'm going to need an angle. I'm going to call it alpha. Let's say the given alpha is, I think I need 2 decimal places. Let's go 36.87. And then we need A. A is going to be the side opposite the given angle. Let's see. Yeah, actually 5 is going to work. So just make sure we identify our parts. Alpha is the given angle. A is the side opposite the given angle. So A is the side opposite. And B is the other given side. We're going to use this B and alpha all day. We're going to be adjusting A because the side opposite the given angle is what determines how many triangles we're going to be looking at, or we're going to be looking for. So we identify that we're in the side-side angle case. We have 2 sides and the angle opposite one of those sides. So we're in the SSA case. That's the first thing we need to recognize. We're in the SSA case. We're in the ambiguous case of the law of sines. We have a set of opposing information. We've got A and alpha. That's what tells us to use the law of sines. So let's set that up. We take the sine of alpha, so the sine of 36.87 degrees divided by A, 5 centimeters, is equal to the sine of beta, this is the first angle that we're going to look for, divided by B, 10 centimeters. We need to use this to solve for beta. So the sine of beta is equal to 10 times the sine of 36.87 divided by 5. So just solving this proportion for beta, we're going to get 10 times the sine of 36.87 divided by 5. And then we need to do the sine inverse of this because we're looking for the sine of beta is this the ratio. And so we need to do the sine inverse. So we grab our calculating machine and we do the sine inverse of 10 sine of 36.87, close the sine, divide by 5, close the sine inverse, hit enter, and we get an error domain. You say, what the heck is going on here? And the problem is, if we look at what we're trying to find the sine inverse of, if we get rid of the sine inverse, oops, now I have a syntax error. the fraction that we're looking at is 1.2, but sine is only between 1 and -1. So we're trying to do the sine inverse. This is not part of what the calculation is. We're trying to do the sine inverse of 1.2. So what angle has a sine of 1.2? No angle has a sine of 1.2. Sine of every angle is between 1 and -1. That's what's happening here. That's why we got an error. And our calculator is telling this error in all caps, so it's like yelling at us. I'm like, oh, calm down, calculator. Because the calculator is capable of doing lowercase letters. It just like, for some reason, has to shout error at you. Eesh, rude. So when we're trying to find the sine inverse of 1.2, no angle has a sine of 1.2. Sine of theta is always between -1 and 1. Sine beta has to be between 1 and -1. No angle has a sine of 1.2 because 1.2 is greater than 1. What this is, the way we read this information, the way we interpret this error when we're trying to find the sine inverse is to see that the side opposite the given angle is too short, and so we're getting no triangles. So the side opposite the given angle is too short, so we have no triangles. That's the interpretation here. The side opposite the given angle is too short. No triangle. This is actually, once we're used to it, your favorite thing to happen when I ask you to solve a triangle in the ambiguous case of the law of sines. There's no triangle, so we're done. We don't have to find 3 things. We just have to find out there are no things, and then we get to move on. So here's a case where the side opposite the given angle was too short. So if we draw a triangle with a b of equal to 10 and an angle of 36.87, the distance between, where this blue point is, the end of the other given side, and the line where the third side should go is more than 5. So 5 is too short to span this distance. It just kind of like dangles there, hangs from this little blue dot. And we can see that if we draw a picture. So if I draw a 10 here and an angle of 37, oh, 36.87, we can figure out what the other given side has to be, the minimum value for the other given side. If we look at this as the opposite, 36.87, we could write sine of 36.87 is opposite over hypotenuse. So that says that the opposite has to be in a right triangle. That's the shortest the opposite could be, the side opposite can be, will be 10 sine of 36.87. And 10 times the sine of 36.87 is equal to 6. So if the side opposite the given angle is less than 6, then that side opposite is going to be too short to make it to the line where the third side should go. So we can calculate the minimum distance, or we can recognize what the calculator is telling us when we get an error here. So let's set up the same problem and just make that small adjustment to the side opposite. Let's see what happens if I make that equal to 6. Hopefully I won't get caught in some rounding error. I think I checked this yesterday, and so I think we're okay. But let's suppose that we're given side B is 10.0 centimeters. Alpha is still going to be 36.87 degrees. And now A, the side opposite, is going to be 6.0 centimeters. This is really hard to land exactly. So I think I tested this, but it might give us an error still. Oh, this is the other given side. And 6.0 is the side opposite. So we can calculate the height. So the height is just going to be 10 times the sine of 36.87. So take the other given side and multiply by the sine of the given angle to get the height. See, the instructions are starting to sound really weird. And that came out to 6.0 centimeters. So we should suspect that this could give us exactly one triangle. This is if I used enough decimal points in the 36.87 or if I rounded things in the right direction. I'm a little concerned that the 6.0 is going to be too small, but only by like the 100,000ths. Let's see if our calculator notices. So we have a set of opposing information. We've got an alpha and an A. So let's take the sine of 36.87 divided by A. And that's going to equal the sine of beta and divide by 10. So beta will be the sine inverse of 10 sine of 36.87 divided by 6. So if we look at 10 sine of 36.87 and divide that by 6, that's a little bit more than 1. And then try to find the sine inverse of the answer. Ooh, I rounded the wrong direction. If you had a professional teacher, he would have checked this more carefully. But instead, you have me. But like I said, it's really hard to land on this one. Should have kept it smaller. Ooh, now we're way off. Oops. It's too far. It's too close to 36.87 and too far from 36.86. I tried to build an example. Oh, you know what? I should have just used a 30, 60, 90 triangle. Oh well, bygones. So it's difficult. At least it's difficult for me. Some other math teacher will be looking at this example, so like, dude, why didn't you just do this one? And then the answer will be, because I didn't think of that one. So the point is, we want to look at the side opposite the given angle. If it's too short, that is, if the side opposite the given angle is less than the height, then we'll have no triangles, because that side will just dangle from this blue point and won't be able to reach the side where the line where the third side goes. Or it could be exactly long enough, in which case we'll get exactly one triangle. What we really need to focus on is, how do we figure out if there are two triangles? What's going on if there are two triangles in play? So that means that the side opposite the given angle is greater than the height, but less than the other given side. So I want to be able to put two triangles in here. We're going to get two values for angle beta. And we might need to figure out how to get those angles. So I knew this was a bad idea going in, but I was kind of crossing my fingers that it would work out. Let's go with B is equal to 10 centimeters. Let's go with alpha still 36.87, even though this betrayed me last time. But now I'm going to make the side opposite the given angle more than the height, so greater than the height of 6, but less than the other given side of 10. So I'm going to say the side opposite the given angle is 8. Here's the 36.87. That's our given angle. The 8 is the side opposite the given angle. And the 10 is the other given side. We can calculate the height as 10 times the sine of 36.87, which we know is 6. So the side opposite the given angle is greater than the height, but less than the other given side. So this is a two triangles case. We just have to remember that the ambiguous case could lead to two triangles. Notice that the fraction that we set up is going to be the same that we set up in the previous problems. Sine alpha over A is sine beta over B. We're still going after beta as our first extra piece of information, our fourth piece of information. So the sine of 36.87 divided by 8 is equal to the sine of beta divided by 10. So B is the sine inverse of 10 times the sine of 36.87 divided by 8. So B is the sine inverse of, so I want 10 times the sine of 36.87 divided by 8. So the sine inverse of 0.75. So that's 48.59. So the problem is there are two angles that have a sine of a positive 0.75 that will fit in a triangle. Remember that sine is positive in the first and the second quadrants. So before we just say 48.59 is our other angle and move on, we have to stop and we have to recall sine is positive in the first and second quadrants. sine is positive in the first and second quadrants, and angles in the second quadrant will fit inside of a triangle. It could be that we have not just a 48.79, but we got to take that 48.59, and use it as a reference angle in the second quadrant. Because we can, angles in the second quadrant are still less than 180 degrees, and it could be that we have an obtuse triangle. So whenever you use the law of sines to find an angle, and that's the fourth piece of information, whenever you're in the ambiguous case of the law of sines, take the 48.59 and use it as a reference angle. So we not only want the 48.59, I also want to calculate the other beta, which is just 180 minus 48.59. So use it as a reference angle and do 180 minus that number. So 180 minus this answer. Because it could be that we have a 131 degree angle. That also fits in a triangle. So now we're in the two triangles case, because both these angles fit inside of a triangle. So now we'd have to find the first gamma. So 180 minus the 36.87 minus this 48.59. So the first gamma is going to equal 180 minus the 36.87 minus the 48.59. One possibility for gamma is 94.54. And then the other gamma is going to be 180 minus the 36.87 we were given minus the 131.4. These are all degrees. So I also have to do 180 minus 36.87 minus this 131.4. And that leaves us with an 11.73. So now we have two different betas, two different gammas, and then we have to find two different C's, one for each gamma. Now this is happening because the side opposite the given angle is greater than the height, but less than the other given side. And earlier, or yesterday, I said you don't have to know which case you happen to be in. So when you're doing the law of sines, the ambiguous case of the law of sines, the first time you find an angle, always just use it as a reference angle in the second quadrant. And tomorrow we'll see what happens if we try this and the side opposite the given angle is greater than the other given side. That's supposed to lead to one triangle. And so we shouldn't have to do this, but we'll see why we won't have to do this. But that'll have to wait. So we still have one case to go. It's because I tried to land that right triangle and I needed more decimal places to make it work out. Dang it. I should have just skipped that. So what you need to do to finish this out is to find these other two C's. And then we need to look at what happens. What if the side opposite is greater than the other given side. All right. So that's going to do it for today. That's going to do it for this week. I have posted some additional quizzes on solving oblique triangles. There's going to be a couple of extras because we're going to have a quiz with the, we'll have some quizzes with the ambiguous case of the law of sines, since there are really three, because I don't want to try that right triangle thing, because the rounding error will get you every time. So next time we need to talk about what happens if the side opposite the given angle is greater than the other given side. So that's it for today. That's it for this week. Go check out the quizzes on the old Canvas section. Everybody have a good day, and thanks for playing.